Let's talk about how stress affects your brain for a minute. Before we do that, why don't we define stress? Stress is a state of disharmony or threatened homeostasis. And so then a stressor is a threat that's either real or perceived that tends to disturb homeostasis. We can list 5 things that cause stress. Uncertainty, lack of information, loss of control, conflict that the organism is unable to handle, and isolation from emotionally supportive relationships. How does stress affect the brain? Studies of early childhood development have shown that stress in early childhood plays a major role in how the brain develops, specifically in areas of the prefrontal cortex and the amygdala. Studies of children who are abused show that when they grow up, they have smaller orbitofrontal cortex volumes than children who were not abused. There's also significant hypothalamic pituitary adrenal axis, HPA axis dysregulation. A study of orphaned children in Romania showed that the longer the children went without being adopted into a foster home, the greater the volumes of their amygdala. This corresponding increase in amygdala size related to an increase in levels of anxiety and levels of internalization behavior. Kids that have depressed moms also have larger amygdala volume. So how early is early childhood development? We know that there are critical windows where the brain has increased levels of neuroplasticity. This happens prenatally, this happens immediately after birth, this happens again at puberty, and we know that stress affects that level of plasticity in the brain, causes changes that last throughout life. We also know that epigenetic mechanisms play a significant role in neuroplasticity and in things like memory and learning. Epigenetics, for those of you who don't know, is like a molecular way for the genes to respond to the environment. If you can imagine a piece of sheet music, the sheet music is like the genes, it's like your raw DNA, and it doesn't really tell you how to play it, but it tells you what to play. And say a person is out and performs this piece of music and the crowd responds favorably when they play a particular piece of this music faster, they can make a note on the sheet music that says, play it faster at this point. That's like epigenetics. It's a way for your genes to respond to the environment that you're in. So I'm not going to get into specifics of how exactly that works with neuroplasticity, but what epigenetic mechanisms do are provide a specific therapeutic target where we might be able to reopen these windows of neuroplasticity. So what do we know? We know that environment does affect brain development. We also know that there are critical windows of increased neuroplasticity that exist at certain stages throughout life. We also know that epigenetic mechanisms offer molecular pathways by which environment can affect gene expression, and in particular, gene expression with respect to neuroplasticity. So where does medicine come in? Is it possible to reopen these critical windows and make positive changes in a stressed out brain?